Welcome, everyone. Today we are exploring a paradigm shift in AI-assisted development, context engineering for code. We'll uncover exactly how Claude Code scans, understands, and remembers your local repository's unique architecture, transforming from a simple chatbot into a deeply integrated senior engineering partner. Let's get started. Let's kick things off by defining context engineering. While prompt engineering focuses on crafting the perfect question, context engineering is about building the environment itself. Think of it this way: prompt engineering is like hiring a consultant for a one-off question. Context engineering is like onboarding a senior developer. You don't just give them a task, you give them the codebase rules, the architecture diagrams, and the tools they need to succeed. Why is this critical? Because when Claude Code tackles long-horizon tasks, it needs a stateful, persistent understanding of your project. If you don't engineer this context, the AI will guess, hallucinate, and break your project's patterns. We achieve this by strategically placing structured knowledge files right inside your local repository. Take a look at this flowchart. It splits AI interaction into two distinct disciplines. On the left, prompt engineering handles short-term, single-task execution. On the right, context engineering builds a long-term, persistent environment. It establishes the tools, rules, and architecture that the AI will use across hundreds of interactions, keeping it securely on track. To master context, you must understand the Claude Code memory hierarchy. This is a multi-tiered system that tells Claude which rules to prioritize. At the top, we have managed policies set by your organization. Next is user memory for your personal shortcuts, followed by project memory, which is shared with your team via version control. Finally, we have highly specific path-specific rules. We need this hierarchy because it allows strict company security rules to coexist with your preferred coding style. How does it work? When you launch Claude Code, it automatically walks up your directory tree, hunting for .claude folders and merging the context. If there is a conflict, the rule closest to your working directory wins, ensuring highly relevant context always takes precedence. This top-down diagram illustrates the memory hierarchy. At the top, in red, is the managed policy which enforces strict organization-wide rules. As we move down, the context becomes more localized, passing through user memory, into the green project memory, and finally down to path-specific rules. Higher boxes set the baseline, while lower boxes provide granular overrides. Let's get practical with project memory, specifically the claude.md file. Think of this file as the central nervous system of your repository. It is injected into Claude's context window at the very beginning of every session. You must fill it with explicit, verifiable facts, exact build commands, testing frameworks, and strict architectural conventions. Why? So Claude never wastes tokens guessing how to compile your app. How do you write a good one? Keep it concise, under 200 lines, and use bullet points. In our deep dive, we emphasize avoiding vague platitudes. Don't tell Claude to write clean code. Tell it explicitly to always use functional React components with strict TypeScript types. Specificity is the key to predictable AI behavior. Here we see the injection process at session start. When you start a session, Claude Code reaches out and pulls data from your shared claude.md file, injecting build rules. Simultaneously, it pulls from claude.local.md, injecting your personal rules. These combined streams equip Claude to deliver truly context-aware coding. As your project grows, your context will bloat. This brings us to scaling context using path-specific rules and dynamic imports. What are they? They're mechanisms that inject context only when it is highly relevant. Shoving every single rule from massive enterprise app into one root file wastes your token limits and confuses the AI. Instead, you create files in a.claude/rules/directory with YAML frontmatter specifying file paths. If you set the path to src/frontend, those rules strictly load only when Claude touches frontend code. Additionally, you can use the symbol syntax within your memory files to dynamically import other markdown files. This allows you to modularize your project's memory, ensuring Claude remains hyper-focused and token-efficient. This state diagram maps out lazy loading context. From an idle state, if Claude opens a Python file, it triggers the backend route, instantly loading the specific backend rules before taking action. Conversely, opening a TSX file routes to the front-end path, loading React-specific rules. It's a smart, just-in-time context delivery system. One of the most magical features of context engineering is auto-memory. This is Claude Code's ability to autonomously write notes to itself that survive across entirely different sessions. The basics are simple. As you work, Claude observes your corrections. Why is this revolutionary? It eliminates the fatigue of constantly reminding the AI about your unique database quirks day after day. How does it happen? You can explicitly say, remember to always use a trailing slash on our API, or Claude will simply learn it organically. In our deep dive, it's vital to know that the first 25 kilobytes of this memory file are loaded at startup. You are always in control. Just type /memory in your terminal to audit, prune, or expand on the notes Claude has written about you. Let's look at the sequence of auto memory. The user corrects Claude, saying we use Redux. Claude immediately adapts the code for the current task, but crucially, it also writes this rule into the persistent auto memory. When the next session starts tomorrow, the auto memory injects this preference automatically, so the user never has to repeat the correction. Even with perfect rules, marathon coding sessions will eventually fill the token limit. We manage this bloat through compaction. What is it? It's a server-side mechanism that compresses your conversation history. Long sessions accumulate hundreds of thousands of tokens. If you hit the ceiling, your requests will fail, and even before that, overloaded context causes the AI to lose focus, a phenomenon called context rot. How do we prevent it? Claude handles this automatically, or you can manually trigger it by typing /compact. The deep dive question is, what survives this compression? Your core context system prompts, Claude.md, and auto memory are fully preserved and reinjected. The messy back-and-forth debugging steps are smartly summarized, giving Claude a clean slate to continue coding. This state diagram visualizes the lifecycle of the context window. We start with a clean context. As the extended coding session progresses, it transitions to a bloated context. Once the token limit approaches, compaction is triggered. The system summarizes the history, explicitly reinjects your core rules like Claude.md, and safely returns you to a highly performant clean context. Let's tie this together with a real-time, highly practical use case, the enterprise monorepo. Imagine your team is managing a massive repository with a Python backend and a React frontend. The challenge, without context engineering, Claude gets confused, accidentally applying front-end TypeScript logic to your backend Python scripts. The implementation, we engineer the context. We put universal Git workflows in the root Claude.md. Then, we create path-scoped rules, one for the backend API and one for the front-end web folder. The outcome is spectacular. When Claude opens a Python file, it strictly loads the database rules. When you ask it to fix a React component, it drops the Python context and dynamically loads the UI rules. This guarantees flawless, unconfused code generation at enterprise scale. This flowchart maps out the monorepo use case. The monorepo root houses the universal Git rules. But as we branch down into src/API and src/web, we hit our isolated contexts. The API branch pulls strictly from the yellow backend rules, while the web branch pulls strictly from the blue frontend rules. Total architectural separation, driven autonomously by Claude. To conclude, context engineering requires governance. You must audit your context files regularly. Treat your Claude.md like production code, review it, and prune outdated instructions. Avoid context rot. If you use scripts to inject context, always check for duplicates so your memory files don't grow infinitely. Be ruthlessly explicit, ban vague statements, and use actionable heuristics. Finally, empower the agent, set the boundaries, and trust Claude to navigate them. Thank you for joining this masterclass. To truly elevate your skills, I invite you to like, subscribe, and visit quicktechie.com for premium certification prep. You'll gain access to massive Q&A banks, full ebooks, audiobooks, full-length training, and expert interview guides. See you there. Our final mind map distills context mastery into core pillars. Governance reminds us to audit files and prune bloat. Specificity demands actionable rules. Architecture leverages path scoping and the memory hierarchy. And the ultimate path to success, visiting quicktechie.com to accelerate your learning journey.